Yeah, well, thank you very much for inviting me. I'm always keen to get on the soapbox and try and shed light on this. I've got about an hour, I think, so this might take about 45 minutes to get through, and then we'll stop for presentation, for questions. First of all, a little bit about me. I'm a former GP, went to medical school in the mid-80s, did my GP training, and then around about 1994, I joined an academic research group in special interest in knowledge representation for the purposes of clinical decision support, especially, whilst also doing a minimum part-time job as a GP locum. I hung up my stethoscope in about 2015, and I've been with NHS Digital, NHS England ever since about 2006. Somebody go on mute. As Ripper says, I've sort of offered, and you may not thank me for this by the end of it all, to give at least two. I think we've got 3 sessions booked in. So the first session of the 3, hopefully, is just a recap of why do we even need SNOMED? What's it for? And then some of the technical need to knows, which I think are particularly important for the analyst. There's a long list of technical need to knows, but I'll pick off the ones I think to start with. Part 2, which I forget exactly when it is, next week sometime, I think, I'll dive into the very murky world of post-coordination, which you may have heard of and will be striking fear in you. And then part 3, actually, I think, is what do we know about what people are actually doing with SNOMED. So some of what I'll be talking about for the first 2 parts is very the theory. And then the last one is what do we know of the practice and what people are actually doing with it and what might need to know. So let's start with why SNOMED. So SNOMED might be seen as being just the latest in a 400-year history of counting clinical beans that started in around about 1665 or 1600 with the London Bills of Mortality and its predecessors. And 400 years ago, they were counting gout, spelt slightly differently, and they were adding up the weekly statistics to produce annual reports of the numbers of people with gout in 1665. Some 300 years later, ICD-1 was born, a flat list of about 100 codes so that it would fit on 2 sides of a sheet of paper, and they were counting gout in 1900. 110 years later, ICD-10, still counting gout. SNOMED was born in 2000, but in 2023, we've got a code in SNOMED for gout. And using that, we can look and see how many times GPs in this country have entered that code into their system over the last 23 years, 12 years rather. And we see an interesting pattern, which clinically, I'm not sure I can explain why the incidence of gout appears to have gone down by a third or so, and is creeping back up since the pandemic. Who knows? But you might think of SNOMED as being just another sort of analytics tool, but it's not really designed for that primary use case. It's really for this problem that clinicians are overloaded with information, and as a result they find it very difficult to apply the latest medical practice on the right hand side to individual patients and individual clinics on the left hand side. And SNOMED is really about, in many senses, closing the loop, that there's limited value in analysing mountains of data about what goes on if we don't have levers to pull to change practice, and that's really what SNOMED is for. So what are the forces for change in this country? Cost, capacity, efficiency. NHS running to stand still has been a standard theme for probably as long as I've been in practice. But certainly a realization in the 1990s, I suppose, that we really needed the whole clinical story to be machine readable and not just the endpoint or summary of what had happened. Particularly, we needed real-time active machine influence over what was about to happen in order to change clinical practice, and not a passive post hoc documentation or counting of what had already happened, primarily for the purposes of billing. And that was already understood in the 80s and 90s. More recently, post-genomic medicine rears its head that we have a vision, still not realised in clinical practice, of needing to select by some algorithmic process the best treatment for the individual patient based on what we know of their genotype, which may be combined with detailed description of exactly how their illness is affecting them, because the patient phenotype is often a proxy for gene expression. So we may all have the same genes, but not all of them are switched on. So if post-genomic medicine is going to tailor medical practice to the individual patient, you need a much richer medical understanding of what's going on. So we need to be able to record accurately what makes each patient unique, not what makes them similar to all the other patients for the purposes of population statistics and trends. And in amongst all of this is the fact that clinicians are really bad at coding. They're not that good at keeping paper records. So we need intelligent data capture that helps them to do this, helps them to capture the detail that is important and to do that in a consistent way. If we're going to have intelligent computer-assisted data capture, then we're going to end up with a computable record. A computable record requires a computer terminology and an information model, database schema, and querying engine, and so on, all of which have to be fully computable. We know that just giving people lists of all the codes they might want doesn't scale. There are more codes than there are grains of sand on the beach that are theoretically possible. We can't list them all. We need to be able to say what we mean as a set of codes, composition, structured group of codes, not as one single code that captures everything. We know, or we knew until ChatGPT, that computers can't read. And so we really need to be able to capture the underlying ideas, not just the vocabulary. We know that humans are very bad at organizing, even if we were to give them lots and lots of codes and try to author lots and lots of codes. We know they're not very good at organizing them into classifications, so you can ask for kinds of codes. And so the task of assembling whatever codes we do provide people with as the building blocks into queryable taxonomies, hierarchies, classifications is a process that needs to be assisted by the machines. You can't leave it to humans on their own. We need knowledge products that reference the computable terminology that are written in terms of it in order to add value at both the data capture and data analysis side. So that could be something as simple as a database that says, I know you've given them this drug, but I also know they've got that condition, and that condition is a contraindication for that drug. And that linkage isn't part of the terminology. At either end of it is a terminology code for the condition and the drug, but the bit between that says these two are related in some way is not a terminology product. But you need those sorts of databases to be written, or those knowledge sources to be written in terms of a terminology. Otherwise, why code at all? And all of this is a big undertaking, and it needs international effort and an international market. And it had become clear by the mid-1990s that for a whole host of reasons, the prevailing technologies of the time, ICD, OPCS in secondary care, and READ2 and CTV3 in primary care, could not deliver all of this. There will be no new informatics without new technology, was basically the gist of it. So for coming at this another way, and I'm kind of assuming here that most of those on the call are familiar with querying HES data and stuff that's coded using what I would call classifications, ICD and OPCS, and perhaps considerably less familiar with how that relates to SNOMED. So I'll come at it from a couple of different ways to give you some kind of handle on the difference. You might think of classifications as being very similar to the kind of phrasebook you might carry around on holiday if you didn't know the local language. And the trouble with those is that, you open the phrasebook thinking, I know what I want to say, but I can't find the one that exactly conveys what I mean to say. And that's because they're a little bit too lack enough granularity to be able to say exactly what you want to say. There'll be a phrase for something close to what you want to say, but it's not really exactly what you mean. And in the same way, classifications, the purpose is to summarize many finished episodes after discharge to explain how they all are broadly similar, in order to support a shallow monohierarchy for statistical returns. By contrast, SNOMED CT offers a grammar and a lexicon, so a set of pieces that can be combined into more or less arbitrarily detailed statements with considerable more detail than is possible in something like the classifications, so that you can describe or aim to describe in more detail the current state of one patient. And that whatever you describe will exist in a deep polyhierarchy where codes can exist underneath more than one ancestor, more than one parent. And it also covers more than just diseases or procedures. So it's not just the grand union of OPCS and ICD, it's also got a whole bunch of other things that go beyond the expressivity that's offered by ICD and OPCS. Another way of coming at it, a postcode analogy. So if classification is about groups of things, so if you ask an investor asks the question, what's happening to house prices around here? And a reasonable analyst answer would be average house prices in this postcode over the last 3 years were this, this, and this. And that's a kind of a useful piece of data. But on the other hand, if you'll focus in an individual, one house, and the owner says, I'm thinking of selling, how much is my house worth? And the best the estate agent can do is say, well, the average price of a house around here is this much. Well, that's no use because your house isn't the average house. Or even worse, can you quote me for painting the outside of my house? And the contractor will say, what kind of house is it? Well, it's in this postcode. That's not a very useful piece of information for that context. So whereas postcodes are useful in some, they're not in others. And that's kind of, if you like, another analogy of the difference between the classifications, ICD, OPCS, and the clinical terminologies. Another way of looking at it is just raw numbers. This bar chart on the far left is the number of individual codes in OPCS 4.9, which is around about 10,000. ICD-10 is a little bit bigger. Read2 is considerably bigger. It's a little bit just under 190,000 codes. But Read2 in the early 1990s was deemed to be too limiting and too small, and Clinical Terms version 3 was devised for general practice, and that's quite a bit bigger than Read2. But they're all dwarfed by SNOMED, which at the moment is somewhere short of 800,000 different codes, of which a large number are drugs, but all sorts of other things as well. So it's compared with ICD and OPCS, it's kind of chalk and cheese in pure size, and that's not necessarily a good thing. And often people say there's a code for everything, and one WAG in one of the GP systems used to take great delight in using SNOMED codes to make a pair of pajamas and a coffee mug and so on. And although there's 800,000 codes, it's still growing all the time. In last year alone, there were 10,000 new clinical codes added to the UK edition of SNOMED and 9,000 new drugs. So it's far more dynamic than OPCS and ICD, not just huge, much bigger, but it's also constantly evolving and changing. So what, people accuse SNOMED of overkill, if you like. There seems to be a code for everything. But this is a grand tradition. Way back in 1665, there was an entry, 1 week of burnt in your bed by candle at St Giles Cripplegate. That was the, if you like, the coded entry, which is awfully precise. More recently, people take pot shots at ICD for having slightly loopy codes. Walked into a lab post subsequent encounter or struck by a duck subsequent encounter are both genuine ICD-10 codes, at least the ICD-10 clinical modification used in the States. Some of them increasingly unlikely. The one last from the bottom, occupant of 3-wheeled motor vehicle injured in collision with pedal cycle and person outside of vehicle, non-traffic accident while working for income, which I think might be a circus act. And even OPCS has some very long and winded codes. So it's not just SNOMED that has codes, very detailed codes. And in the third part of all this, we might look at whether people actually use that level of detail that's offered to them. So that's a very whistle-stop tour of kind of why SNOMED was devised, what it's really for, and how in some ways it differs from things you might be more familiar with. And the next bit I want to move on to is some of the technical needs to know specifically about SNOMED. And there's quite a lot of these. This list even here is just a limited set. And I just want to focus on the 3 in black here. Post coordination will kick over to the second session. And so for today, I'm going to look more at the sort of the transitive closure table, which is something you might have heard of, how to query SNOMED and its taxonomy. And another phenomenon which is not unique to SNOMED. It was already present in Clinical Terms version 3, the primary care thing, but it's not something you see in OPCS or ICD. And this is the notion of concept inactivation and its consequences. But where I want to start is a cautionary tale and my bête noire in all of this, which is Microsoft Excel, which is the go-to tool of the NHS for doing pretty much everything very often. But it does not play nicely with codes generally, and especially not with SNOMED codes. So this is a problem for when standards are not your friend. So by way of an example of the problem, and also to demonstrate that SNOMED is not the only thing that suffers this way. This is a list of codes on the left-hand side from Clinical Terms version 3. So this is a terminology which was used or is still used really in one of the 2 leading suppliers to the primary care estate. So this was adopted by TPP System 1, which currently has about 40% of all GP practices in this country. So it's an innocuous looking list of a 5-character code and what that code means. The ones that put towards the bottom, 6/4 means I can see at 6 meters what I should be able to see at 4 meters, I think, was it the way around. So you've got very good eyesight, you can be further away and still make it out. Actually, whereas 6, the other way around, I think, yeah, anyway, yes. So those are all visual acuity measures of how far away from something you have to be before you can see it compared to the normal person. So if you copy that list as just plain text on the left-hand side with the tab character between the code and the text, and you paste it directly into a freshly opened Microsoft Excel worksheet, you'll see that appear in the center. And if you then recopy that and paste it back into the same text editor that you took the list on the left from, you get this on the right. And you can see that some things have been changed. The first 5 codes have somehow been interpreted in some slightly odd way. And all those 6/4 type things have been turned into dates by Microsoft Excel. So it's trying to be helpful. It's kind of assuming the data you pasted in is the usual sort of stuff. And has massaged it appropriately in ways that are not in this context actually helpful, and so they can degrade the codes. And this has been known not just in CTV3, but lots of other coding systems behave in the same way. Not all the codes and not all the terms, but there are some that do. And in the context of SNOMED, there's an extra problem, which is IEEE 754, which is an IEEE standard that is agreed or is sort of part and parcel of all spreadsheet systems, not just Microsoft Excel, but Google Sheets and all the others, where they agree to only store very big numbers up to a certain level of precision. And the consequence of it is this: if you take this list of SNOMED codes and their terms on the right, on the left-hand side, again, copy them as plain text, paste them straight into Microsoft Excel, copy immediately what you just pasted in and repaste it back out into a text editor, you get that, which looks very similar, except that some of the numbers have been degraded to a 0, which means that those are no longer SNOMED codes. They're not just no longer the same codes, they're no longer SNOMED codes, they're just random sequences of numbers. And if you go looking for those sequences of numbers in any medical data, you will not find them. So it's been corrupted in translation through Microsoft Excel. And this problem is pervasive throughout many of the analytics stuff I've seen over the last few years. So here, for example, is the MIM 4.2.00. This is the specification which last year, I forget when I took this off the web, but it was a public document. And it looks fine, except there's a fair number of the SNOMED codes which are inactive, of which we'll learn more later on. There's a whole swathe of them at the bottom on the right, which have suffered from that code corruption thing quite dramatically, actually. You know, the last half of the codes have all been degraded to a 0, and I still don't know exactly how that's happened. There's a bunch of the term strings on the top right, which are truncated. So they've just taken the first part of it, and then the last, everything after the 50th character, for some reason, has been cut off, which makes it slightly difficult to use. Here's another one, care.data specification, 2 parts of the care.data specification from a while ago, admittedly a decade. So on the left-hand side is the set of CTV3 codes that indicate the data might be sensitive to patients, I think. And if we look at that list, there's a few things. This code here, another sort of wrinkle in Microsoft's behavior, what should be a 5-character string, followed by a percent symbol, because everything else in that list is a 5-character string plus or minus a percent symbol, is actually a 4-character string, including the percent, because what were typed as 3 full stops has been turned into a single ellipsis character, which looks like 3 characters, but is in fact 1. And so again, if you went searching for that 3 character, you won't find it. It's not a read, it never was a read code. But apart from that, everything on the left-hand side does appear to follow the format of being a 5-character string, optionally with this percent symbol attached to the end of it, which means this code and all of its descendants in the hierarchy. The same specification on the right-hand side has another file taken from version 2, but the code formatting is different. They're not all 5-character strings. Some of them are just 3. So either these are all wrong or they're using a different syntax. And so, you know, there's a combination of invalid codes. It just makes the process of checking that everything's not been corrupted very difficult if different syntaxes are used. And Microsoft Excel, of course, doesn't enforce anything. Here's another more recent one, the shielded patient list, part of which was borrowed from, or a recycling really, of the SNOMED CT flu mapping code set. And when I downloaded that a while ago, a few years back, not many, there was a large number of codes which had been corrupted by IEEE 754. Altogether, there were 2,150 SNOMED codes in this particular bit of the specification, within which there's 33 outright code transcription corruption errors, thanks to IEEE 754. 72 codes were now inactive in modern day SNOMED. And there were around 1,200 known already inactives missing. So although there were 72 actives, there was another 1,200 they could have added. And we'll look at what happened, the consequences of not doing that later on. So it was missing codes that could be in patient data. They mostly only selected active codes. For example, and just to make the point, within this list is this code 83270006, which is the code for a pleural effusion caused by cancer of probably the pleura. And we know that GPs had used this code about 13,000 times in the last decade. So not a high volume, but it's a very serious condition. And in the context of COVID and shielding, possibly quite serious. Unfortunately, however, the code became inactive, was made inactive in the UK's edition of SNOMED from October of 2020, as a consequence of which it should, in theory, no longer be selectable by many UK clinicians, but it may already be in the historic data. There's nothing to stop them prior to October. It was perfectly fine for them to use this code. After October 2020, they shouldn't have been. They should have been using one or two different codes. But in the shielded patient list, neither of those two newer codes were in the list, and so would not be found. Another one, Q-COVID. There was I was asked to get involved in looking at a list of codes that were part of trying to put together a specification for risk scoring patients with COVID. 712 different codes in the list. 12 of them are unique to EMIS. You won't find them in any other system. 30 of them had lost their check digit thanks to IEEE 754. So the last digit is a 0 in all of these when they shouldn't be. And so none of those are SNOMED codes. 137 were even more dramatically corrupted in the way that I say I don't quite know how this happens, but none of those are SNOMED codes. So as it stood at the time, a large part of this specification was in fact junk. So be cautious of using Excel in maintaining codes at all, but especially with SNOMED. There are ways around it. Some people have tools or gizmos that append an alpha character to the front of the code, sometimes a full stop, something fairly small, and then they have to strip it out later on. Or you can tell the entire spreadsheet before you paste your codes in that it's all text, not numbers. So don't use any of your fancy standards for handling numbers. There are ways you can do it, but we know that people forget. And so ideally, we should be using something different to Excel to maintain all this stuff in. But the next bit is more about how we kind of use the structure of SNOMED. So you may be familiar in an ICD and OPCS context with being able to answer, rather than being passed a list of codes, to ask a more general question of, like, find me all patients with a particular condition like asthma, for example. And on the left-hand side here is a hierarchy actually taken from RE version 2, but it's similar to ICD. We can see the code H33 2 dots asthma. And then all the codes that encode for more detailed kinds of asthma all share the feature of starting with the same code letters, H33. And so one of the cheap ways of being able to answer the question, give me all codes with asthma, is just to a code string comparison. As long as the code begins with H33, then I know for a fact it's going to be a subtype of asthma. And that way of answering those kind of tree structure, hierarchy, subtree, extract type questions is quite common in ICD and OPCS. Although OPCS has some features which mean that it actually doesn't always work even in that classification. But this kind of way where the structure of the coding scheme is built into the letter of the code itself was very much the way that things were put together in terminologies and classifications up until about 1995. The main limitation with that approach is that you can't have a code that's a kind of more than one parent. And whilst monoaxial schemes, where there is only one parent for everything, are great for statistical analyses because you can only be in one bucket, they're not good for decision support. And so CTV3 and SNOMED and other schemes around the world realized they needed to get away from this system of having the structure of the classification scheme, the parent-child relationships between codes conveyed within the code itself. So the same hierarchy in SNOMED of asthma codes on the right looks like that on the right-hand side. And it's, you know, there's no way looking at the numbers on their own and working out that they're all, in fact, a subtype of the code at the top for asthma. So it has to be done by some other method. So one way of doing it, I'll show here. So imagine that somebody stuck the code for XA4G7. This is an example from CTV3, again, to point out that SNOMED isn't the only kid on the block that does this. So we've got XA4G7 in the patient data. They've got unstable type 1 diabetes. And the question is, who's got an endocrine disorder with a different code, X40GD? So how do we answer that question? So somewhere in the coding system out of the box will be a data table that tells you what the parent-child relationships actually are. And so we can look that up and we'll find that the code at the bottom, the one in the patient record, has one parent, which is the code X40J4. Well, that's not the code we were looking for, but we haven't stopped. We haven't hit the top of the tree yet. So let's keep going and ask everything recursively for the parents until we either hit the top of the tree and there's nowhere else to go, or we meet the code that was the original exam question. So we walked up from one child to its parent, and so on. And in this case, we found, yes, I can follow that chain, that breadcrumb trail to the top, but only by recursively querying indefinitely many times the out-of-the-box parent-child relationship table. And this is kind of tedious and sometimes quite slow. So it's usually not the way that these sorts of queries are actually answered. A much faster way is to pre-compute what's called a transitive closure table, which is basically saying the is-a relationship has the logical property of being transitive. If A is a B and B is a C, then I can tell you that A is a C, because I can hop across indefinitely many is-a relationships. And if I do that, if I pre-calculate every possible, not parent-child relationship, but ancestor-descendant relationship that is possible to conclude from the set of parent-child relationships, I end up with a much bigger table, 11 million rows in the case of SNOMED. But I only have to do one lookup, so I can answer the original exam question. If there is a single row in that whole table where that pair appear, then I can say, yes, one is a descendant of the other. And so usually these sorts of subtype queries are done using this much larger transitive closure table, much larger by comparison with the parent-child relationship, but it's a pretty quick lookup in most cases. Just as a side note, if they're new specialists, there are some RDBMS languages which you have a connect by operator. That essentially means you don't have to explicitly build a transitive closure table. The database engine itself will effectively do that behind the scenes for you without you realizing that's what it's doing. But that solution doesn't work in the context of other requirements in SNOMED, so I wouldn't recommend it. So as I said, the solution to straightforward subsumption testing is this thing called a transitive closure table, an exhaustive list, pre-computed, of all the ancestor-descendant pairs that hold true, but they can be quite beefy, and you don't have to have them just for SNOMED. You can do it for ICD, and that's not a huge table, but they are quite big by comparison with the sorts of structures people are used to having. Okay, so the next detour is into the problem of concept inactivation, and the wider problem that if the reference data can change, not just adding new codes in the way that I kind of said earlier on, there's 10,000 new codes a year, but if the codes that already exist, have already been issued, can themselves change in certain ways, particularly concept inactivation, then nothing that you build out of the terminology, query specifications and so forth, can really be treated reliably as static, is the take-home point. So this slightly busy slide, I'll try to explain before I do the animation. So the problem for all terminologies, classifications, including ICD and others, is that from time to time, even with the best will in the world, mistakes are made by the authors that maintain them. And one of the common mistakes is to put more than one code in that means the same thing. There are others. And when that happens, if you're in a classification like ICD or APCS, there's not a lot you can do about it, because there's no kind of, you can't just delete the code usually, and there's no kind of mechanism for graceful tidying up and cleaning the mistakes. And both Clinical Terms version 3 and SNOMED take a different approach and say, well, we'd like the hierarchy of codes to only have one unique code for each meaning we want to capture. And when we discover duplicate pairs, we will inactivate one of them and move it out of the hierarchy into a kind of a limbo bucket where it doesn't have any kind of parents or ancestors at all. It just, we keep it on file that it used to exist, and I can tell you what the labels are, but it doesn't have any ISA relationships to anything much else. So this slide tries to demonstrate that. On the right-hand side, in the kind of light blue or grey, are the active codes with black arrows that indicate the ISA relationships, parent-child relationships between them. And on that side, you can see at the bottom right that recurrent chest infection at some point in SNOMED's history, with a code beginning 3081, was known to be a kind of lower respiratory tract infection, which in turn was a kind of respiratory tract infection, which in turn was some kind of disorder, and so on. So kind of truncated SNOMED taxonomy on the right-hand side. On the left-hand side is a snapshot of what was true in SNOMED, small corner of it, as of October 2011, when there were two other codes in orange, one an upper respiratory bacterial infection code, and another actually also saying recurrent chest infection. So identical wording to the one we saw on the right-hand side, but a different code, 195746005, which had always been inactive in SNOMED since the very beginning. But it doesn't have an ISA relationship to any of the clinically familiar codes on the right-hand side. What it does have is the horizontal blue same as relationship that says, I'm inactive, but I'm telling you I mean the same as this thing over here. However, if you naively query SNOMED in the traditional way for respiratory tract infections or any subtype of it, if you only consider the black relationships, the black arrows, which is what you'll see in a transitive closure table, then you're never going to find those two orange things because they're not linked in. But that code on the right-hand side up until 2011 could have been perfectly legitimately added to clinical records. But after 2011, it was also made inactive for reasons I won't go into, and moved over to the left-hand side. And a new code created. I think the problem was that chest was felt as a word to be a bit ambiguous as to what you meant. And I'm not sure that clinicians would have agreed, but the authors who maintained SNOMED at the time decided that chest infection wasn't as clear what it meant as recurrent lower respiratory tract infection as the preferred term. So they put that in, and they put some more blue arrows with a slightly different flavouring across. But again, the consequence now is you've got that orange code in your data. People have already been putting it in up until 2011. And now suddenly they can't do that. OK, now they're going to use the code on the bottom right-hand corner instead. But how do you query the historic data? Whereas in the past, your query for respiratory tract infection and all of its descendants didn't find these two dark grey things, now it's not going to find that either, even though there's data in the clinical historical record. And this ongoing sort of tidy up in SNOMED continues. There are, codes which are reasonably commonly or were reasonably commonly used in UK primary care, for example, up until they were made inactive. All at the same time, I think in July 2020, the code for a cough, or rather chesty cough, I should say, was killed off. Acne vulgaris was killed off, and so on. So they're not necessarily edge cases, codes that move from the right-hand side of the previous screen over into the left-hand side, where you're not going to find them unless you do something slightly different. So what's the effect of inactivation on the EPR as it grows? So this slide I'll try to explain. So this is asking the question, if I were to have used SNOMED as it was in 2018, in which codes that had previously in earlier years been active had since become inactive by 2018, what's the effect of looking at the record as it was added in the years going backwards from right to left in this case? The slide's kind of back to front in some ways. So if I were to look at the data entered in 2017 using the SNOMED as it was in 2018, I would find a very tiny percentage, that little red line at the bottom, of all that data had been entered in 2017 using a code that became inactive in 2018. If I go back 1 year further and look at all the data entered in 2016, there's a little bit more. And so on over, if I look at the data that had been entered during 2011, something like 5% of the data, so right, or maybe 3% of the data at that point in time was inactive, and therefore would not be found using the traditional transitive closure table approach of querying SNOMED as SNOMED was 9 years later in 2018. Now you might say 2.5% of data that I might not find, that's not a big deal. But of course that ratio is not constant for all clinical areas. And so in the case of mental disorder, for example, it was 6.5%. So it starts to become potentially relevant depending on the particular clinical area that you're kind of looking at and whether your use case can tolerate not necessarily finding all the patients who clinically are eligible, and also finding a different answer to the same question when asked maybe even a week earlier using an older version of SNOMED. And so this kind of gradual rust of the data is an important problem. It's essentially the price of perpetual progress of cleaning up SNOMED and trying to make it better is perpetual change for all the things that depend upon it. Your code lists are for life, not just for Christmas. Don't link your reproducible analytical pathways to static unversioned code lists if possible. Try to link them to dynamic list servers, which will always give you the more recent version and take up a lot of the strain. And maintenance and clinical assurance of any code lists for data extract or even for data entry will be much more frequent than people might be used to with ICD and OPCS, where those code lists change fairly infrequently, once every 3, 4, 5 years. And often by not very much. Whereas SNOMED, that sort of drip feed of 10,000 new codes a year is gradually accelerating. The numbers are going up. And instead of coming out twice a year, it's now coming out 7 times a year. So there could be new codes being added all the time that might be within scope of a query. And depending on how enthusiastic clinicians are in taking advantage of those new codes, then that rust may kind of creep up on you quite quickly. So in the context of asking the sort of subsumption question, what are the codes that are a kind of another code? How do we deal with this inactivation problem of codes moving out of sight of the transitive closure table? If you only consider the ISA relationships by whatever technique, it's never going to be sufficient. You're not going to find all the eligible patients, and the numbers that you don't find will be variable depending on which bits of SNOMED have been more actively maintained and cleaned up recently. So we need a way to compute those blue arrows to include those in our query specification. So it's not just the black arrows we take account of, we also take account of the blue ones. At the moment, this situation is changing a little bit. So what I'm about to say might become slightly out of date in a year or two's time. Prevailing technology at the moment is in two parts. The first of which is something called the substitutions table, which is a sort of derived pre-computed add-on to SNOMED that we publish to go alongside it and sort of help with this problem. What this gives you is a list of code. So one possible architecture of using this, it's a table that tells you this code is inactive and here's its replacement. So if you like, it's an easy way to get a list of those blue arrows. So one way of using that would be to say, well, OK, every time I run a query, I've got a query specification that includes codes. It might be a list of codes. It could be some other slightly more condensed specification. But if anything in that query specification turns out to be inactive, then I look up in the substitutions table its recommended active replacement and just substitute those in. And equally, or alternatively, if I've got inactive data, inactive codes that have already been committed to a clinical database, then again, I could look up for each of those the active substitute and overwrite or append in my clinical reference data, the real patient data, with the newer code, and then everything will work in theory. But this is kind of slow and tedious and has its own problems. And there is another way. And the other way is to basically merge the transitive closure and or join them together, the transitive closure and substitutions table, into what's known and distributed as the SNOMED query table, which is used in tandem with the transitive closure table itself. So the combined product is some 20 million rows to query. But this architecture potentially gives you on-the-fly transformation of all possible data or queries without actually having to change either. And so this is still, I think, the recommended sort of engineering solution to avoid having to, every time there's a new SNOMED release 7 times a year, scurrying around, rewriting all your clinical data to put in the replacement codes and looking at all of your query specifications and updating those using the substitutions table as on the previous slide. It's not a complete get out of jail solution. So I think we would still say that the query specification should still be actively maintained using the substitutions table to help as per the previous slide, but at least we don't have to kind of stop everything 7 times a year, probably, to make sure that everything's in lockstep. So there are solutions, but it's a more onerous maintenance than people might be used to. And to, another way of illustrating why do we need to do this. So here's an example from a real hospital in London. And the exam question here is I want to see how, go backwards slightly. There were 900,000 attendances over a period of several years to one A&E department. And each attendance got one SNOMED code to say why they came. So the exam question is, how many patients, what's the time trend, appeared in that department over 7 years with a complaint that might be counted as an abdominal presentation. And so for the purposes of this slightly noddy exercise, I decided that I was therefore going to count as abdominal presentation everything in the yellow box: appendicitis, acute constipation, chronic constipation, diarrhea, hyperemesis, Crohn's disease, abdominal pain, rectal hemorrhage, jaundice, and all the codes in SNOMED that sit underneath those in the most part. So that's a largish list of codes. And if I run that query against that database of 900 or so sequential attendances, there are 151 different codes that were used at least once. And a total of 47,000 episodes of attendance. And the time trend is that blue line you can see on the left, which has a very obvious discontinuity in it. Something very strange happened in 2012. And the reason is there was some concept inactivation. And at the moment, this query is being run without taking account of the inactive code problem and the fact that some of the data had been put in using inactive codes. And if I drop in the query table that I mentioned as an engineering solution and rerun the query, some new codes appear that were not previously being counted because they were just invisible to the query technology. And the blue line is replaced by a rather more plausible grey line as to what the time trend actually was for the list of codes that I was interested in. So that's the kind of impact of either forgetting about inactive codes or trying to deal with them.